Hi guys, welcome to another video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There's a lot of information out there. Be aware that I'm not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today we're going over 8.2, which is writing linear equations. So we're going to be going over how to write linear equations, how to identify independent and dependent variables, how to chart your information, and then graph your equation. So our first definition to go over is linear equation. This would be an algebraic equation that has a dependent and an independent variable. The graph of this equation is a straight line. So, an example of a linear equation would be y equals x plus 10. So notice we have two different variables, two different letters. We have x and y. Now, this setup usually has a pattern. The variable by itself is typically going to be your dependent variable. The letter on the opposite side that's not by itself, so this x, for example, is typically going to be your independent variable. So what does this basically mean? It means this letter depends on what's going on over here. So I need to know what x is so I can add 10 to it so I know what this variable is going to be. So in this situation, y depends on x. So your variable that's usually by itself is typically your dependent variable. And this pattern is typically always going to be true. So we're just going to make note of that. This pattern or setup most of the time will be true. There may be the occasional time where it doesn't work out like that, but pretty much most of the time, the variable by itself is going to be your dependent variable. The one not is going to be your independent. So that's a good pattern to go by, or a good rule to go by. All right, let's discuss our variables, dependent and independent. Dependent variable. This is the variable whose value depends on the value of the other variable. What's the other variable? We're referring to the independent variable. So the variable whose value depends on the value of the other variable, or depends on the independent variable. When you're graphing on your x and y axis, your y-axis being the vertical and x being horizontal, your dependent variable is typically going to be on the y-axis. All right, our next one, independent variable. This is the variable whose value will affect the value of the other variable. The other variable being the dependent. And again, if you're going to graph this on your y and x axis, your independent variable will typically be found on your x axis. So, independent, the variable that you typically manipulate in an experiment or some type of situation, your dependent goes on your y. So these values will depend on these values. All right, first example. So we're going to be writing linear equations, identifying independent and dependent variables, and then we're going to get into graphing. All right, so our first example. Jacob is X years old. Jenna is 10 years older than him. If Jenna is Y years old, write an equation that relates their two ages. Name the independent and dependent variable. So we have three tasks. First, we need to write the equation. And second, we need to name the independent variable and the dependent variable. There's a couple different ways you can approach writing a linear equation. First, we're just going to jot down our information, our for sure information. I for sure know Jacob is X years old. I for sure know Jenna is Y years old. Now, I could approach this different ways. I could look for shortcut terms, which there are none. I will show you what they look like in other examples. The main way, though, is to look for the sentence that relates both of them. So I have Jenna and him. It's talking about Jacob. So this sentence right here relates both of them. So I'm going to use that as my sentence starter to translate into my equation. So I'm just going to summarize and say Jenna is 10 older than him. And again, him is referring to Jacob. And I'm going to use this sentence and slowly translate it and change it into numbers, letters, and symbols. So first, Jenna. How old is Jenna? We noted that Jenna is Y years old. The next word, is. Is our equal sign. So we're saying Jenna is equal to, well, how old is Jenna equal to? Remember, equations, whatever is on the left is the same as on the right. So this is about Jenna. Jenna is Y years old. How old is Jenna? Well, she's 10 older. What does 10 older look like? 10 older means add 10 or plus 10, 10 more than someone. 10 more than who? Than him. Him is Jacob. How old is Jacob? Jacob was X years old. What am I going to do with that X? I'm going to take that X and put it right in front of my plus 10. So this equation tells our story of how old Jenna is. Jenna is 10 more than Jacob. Order is important, even on addition. So this is our equation. That's our first answer. Y equals X plus 10. The second, it wants to know the independent and dependent variables. So what depends on what? Now, if you remember our pattern from above, we said the variable by itself is typically going to be your dependent variable. So in this case, Y is by itself. So that means our dependent variable, and I can't spell dependent apparently. Let's try that again. Our dependent variable is y, so Jenna's age, essentially. Her age depends on Jacob's age, which is x. Because if Jacob is 1 year old, add 10 more, and you're going to get Jenna's age, which would be 11. So her age depends on his age. So dependent variable is y. Our independent variable is going to be x. Again, these are variables, so we are expecting letters. You would not write Jenna or Caleb. Not Caleb, sorry, Jenna or Jacob. I know who's in this story. So that would be our second and third answer, technically. All right, our next one. This one has a shortcut term to get started. All right, this is, or says, a rhombus has sides of length r centimeters. So here's a picture. Notice you see these dash marks. These dash marks mean all sides are the same. So if this side is r, that side's r, that side's r, and that side's r. Okay, let's continue. The perimeter of the rhombus is capital P centimeters. Express P in terms of r. Name the independent and dependent variable. So you'll notice that this question had different phrasing than this one. This one said, write an equation. This one says, express P in terms of r. This is our shortcut phrase. If you see this phrase right here, express P in terms of r, or express X in terms of Y, or express anything, what does that mean? Well, in this situation, express P means you're going to write P equals, and basically something with an R on the other side. So some expression with R. So express P in terms of R means start with P equals. So this tells you exactly how to start, with what letter to start with. All right, so let's find out what we're talking about. We want the perimeter of the rhombus. What is the perimeter going to equal? Well, it's going to equal adding up all the sides. All right, we're going to use this and translate it. So I already know, because of this phrase right here, express P, that I should start with capital P. And that fits with exactly what I just wrote. I want the perimeter. Perimeter, they said, use capital P. What does it equal? Well, we said add up all the sides. So I have 4 sides, and they're all the same. R, 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 and R. So R plus R plus R plus R. That's not simplified. So let's simplify it. Capital P equals R plus R plus R plus R is 4R. It's been simplified. So the perimeter is equal to 4 times all of the identical sides. And this only works for this shape because all sides are the same. So that's our first answer. Our equation is P equals 4R. We express P in terms of R. Okay, we still have to name the independent and dependent variables according to the question. So, dependent variable. Dependent variable is going to be the variable by itself, in this situation, capital P. So, the perimeter, which is what P stands for in this situation, depends on the side length, which is R. So that's going to be our independent variable, R. Not 4R. 4 is not a variable. Variables are letters. So dependent, independent variables, you're looking for your letters. All right, next. All Our next situation says, Frodo has D dollars. Sam has 4 fewer than Frodo. He's very sad about that. Sam has Y dollars. It says, express Y in terms of D. Name the independent and dependent variable. So you'll notice it has this phrase right here, express Y. Again, that means you can immediately start with Y equals. So that's a shortcut phrase. So I'm going to have Y equals and something with D over here. All right, let's jot down some information. Frodo, for sure, has D dollars. Sam has Y dollars. All right, I could simply start with Y equals, or I can look for the sentence that relates both Frodo and Sam. I'm going to kind of do both. So here our sentence is, Sam has 4 fewer than Frodo. So Sam has 4 fewer than Frodo. I already know it should start with Y equals. Let's see if that comes true. Sam, how much does Sam have? Sam has Y dollars. See, it works out. Perfect. Y. All right. Has. Has is another word for equals. So Sam has, how much does Sam have? Again, so this equation is going to be all about Sam. Sam is Y, and now I'm going to describe what Sam has. Sam has 4 fewer. 4 fewer means subtract 4. Like if you have 4 fewer cookies, well, you would have, well, take away 4, and that's how many cookies you have. And you're not as happy because you want more. The same is true with money. All right, next, 4 fewer than who? Frodo. How much does Frodo have? Frodo has D dollars. Where are you going to put that D? You're going to put it right in front. So let's see. Sam has however much Frodo has, but take away $4. That sounds about right. So that's our first answer, our equation. Y equals D minus 4. Sam has 4 fewer than Frodo. Order matters. Second, it does ask for the independent and dependent variables. So dependent, the variable that depends on the other, is going to be Y. Why is that? Well, Y stands for Sam, and Sam's money depends on how much Frodo has. Because Sam has 4 fewer dollars than Frodo, so if you don't know how much Frodo has, you're not going to know how much Sam has. So dependent is Y, it depends on Frodo. So our independent variable is D. And again, you can just simply follow that nice pattern that I gave you at the beginning, which states the variable by itself is going to be your dependent, and it depends on the other one, which will be your independent variable. All right, I think we've answered everything we need. Now we're going to take it one step further. We're going to chart it and graph it. Number 4. The length of a rectangular picture frame is going to be 5 inches longer than the width. So the length is 5 inches longer than the width. We're going to let capital L represent the length and lowercase w represent the width. Because why not? Write an equation that relates the width and length. So you'll notice there's no shortcut phrase. It doesn't say express. So I don't know if I should start with L equals or W equals. If you have a chart though, there's a shortcut there. And I'm going to show you that in a second. In the meantime, we're going to do this the hard way. We're going to look for the sentence that relates both length and width. It's going to be this one, this whole sentence. The length is 5 longer than the width. So you'll notice what I underlined. That's what I'm going to use for my start. So the length is 5 longer than the width. We're going to slowly translate that into letters, numbers, and symbols. Length said, let capital L be the length. The word is going to be our equal sign. So the length is equal to this. What is this? Well, 5 longer means like 5 more. So that means plus 5. So something plus 5. 5 more than what? The width. What is the width? It says lowercase w. So what am I going to do with that? I'm going to put it right there in front of the plus 5. So let's just check and make sure this fits the story. The length is equal to 5 more than the width. I know it kind of goes backwards, but order is important. It looks like it checks out fine to me, so that's going to be our answer. Capital L equals W plus 5. The length is equal to the width plus 5 more inches, essentially. All right, it does not ask for the independent or dependent variable. However, for the sake of these notes, we're just going to identify them real quick. Variable by itself is going to be our dependent variable. So the length, essentially. It depends on whatever the width is, which will be W. So that's our independent variable. Okay, now I mentioned there is a shortcut if you have a chart. So how would I know, besides using this sentence as my start, that the length is what I start with? L equals, in other words. Well, charts follow a pattern. The top row of your chart is typically going to be your independent variable. So the top row is your independent. So W would be your independent variable, and the bottom row on any table is typically going to be your dependent. Now you might be like, how is that going to help? Well, remember, the letter we start with is typically our dependent variable. What does that mean? If the bottom row of a chart or table is your dependent variable, meaning L, that means you're going to start your equation with L. So that would have been a shortcut. So if you didn't know if I should write W equals or L equals, you can skip ahead, look at the chart, and say, oh, the bottom row is L for length. The bottom row is dependent. That's what I start with. So that means I should start by writing L equals. Where would you go from there? Well, you ask, what does L stand for? Length. And then you ask, what is the length? Well, the story says it's going to be 5 longer than the width. So that's where you would come up with 5 more than the width. And you'd be able to finish your equation. Okay, let's move on. I have 5 empty spots. What kind of work would your instructor expect you to show? Well, if you're learning about equations, they're probably going to want you to write your equation 5 different times. So what is our equation we came up with? We came up with L equals W plus 5. Is writing it once enough? No, absolutely not. So let's do it 5 times. L equals W plus 5. L equals W plus 5. L equals W plus 5. And once more. L equals W plus 5. Got to practice it while it's easy. All right, now, what is L? I want to know this box. This box stands for L, essentially. What is W? It tells you right up here. The top row is W. So in this situation, W equals 1. So what are you going to do? You're going to replace the W with a 1, just like this. So L equals 1 plus 5. What are you going to get? 6. I know what you're thinking. Can't I just do 7, 8, 9, 10? Well, if you're just learning patterns, but we're not learning patterns here. We're learning how to write equations and solve equations. So, show your work. So, L equals, what is W this time? 2. We're going to add 5 to it according to the equation, and you get 7. Next, L equals, what is W this time? 3. So 3 plus 5 more, you're going to get 8. I know, I can write 9 and 10, right? No. Show your work. L equals, W is 4 in this situation, plus 5 more inches, you get 9 inches for the length. Last one, what's the length if the width is 5 inches? It's going to be 10. Now, why can't you just use these patterns? Life doesn't always follow a pattern. What if you had something like, I don't know, 73? I mean, sure, you can use pattern, right? No, not really. So you have this nice equation that tells you exactly how to do it. L equals, well, W in this case would be 73. Add 5 to it. So L equals 78. So the equation helps you when there's no patterns present. If there are patterns present, come on, just show some work. All right, let's continue. Part C, we're going to graph the relationship between W and L in a coordinate plane. So what does that mean? Start by, if you don't have grid paper, drawing your X and Y axis. So here's your Y axis. Probably drew that too close to the bottom. Draw your X axis. If you need to extend later, do so. Hopefully you're not doing this in pen. All right, there are 6 parts to good graphs. Well, in general, sometimes more is needed. First, we're going to start with title. So what is this about? Let's review. Length of the rectangular picture frame is 5 inches longer than the width. We're writing an equation that relates the width and length. So essentially, this is about the length and width of picture frames. Your title should essentially tell you what you're going to be looking at. All right, next, we need an X title, so X-axis title, and a Y-axis title. So title, 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 3 titles. X-axis title is on the bottom. This is your independent axis. So if you're following the pattern on the chart, it kind of flips. The independent was the top row. It's now going to become your title on the bottom. So all you have to do is copy this, and that's your title, width, inches. So our independent axis title is going to be width, and we're measuring it in inches. You must have your labels. All right, next, the Y-axis title, your dependent title. The dependent variable is length, and it's measured in inches. So, length, and it's measured in inches. Be sure to leave room for your numbers. So, essentially, those are your titles. Don't know what that is. So your titles come right from there. All right, let's continue. What else do I need? I need my X-axis numbers, and I need my Y-axis numbers. So X-axis numbers, again, that's your independent axis. How are we going to do this? Look at your lowest number, which is 1. Look at your highest number, which is 5. You want to generally start at or below the lowest and stop at or above your highest. Be careful of what you need to count by. Typically, you can kind of choose what to count by. Since it's just 5 numbers and they all count by 1s, it would be most reasonable to start with 1, count by 1s, and end with 5. Do not count by 2s, don't count by 3s or anything else. That would be ridiculous. So, 1, 2, and you'll notice I'm spacing my numbers out evenly. 4 and 5. And again, sometimes it's helpful to go a little farther if needed. Next, your dependent axis. So I'm going to look at my lowest, 6, my highest, 10. I usually want to start at or below my lowest and continue to at or above my highest. So I'm going to go with, or start with 5. All right, I need to get to 10, so I'm going to go ahead and count by 1s. So 6, 7, notice I'm spacing my numbers out evenly, or as evenly as possible without graph paper, 9, and 10. Now, one thing. Here, I started with ones and I counted by ones. Good. Here, I counted by fives. Did I count by fives? No. That means you need one of those. That would be called a break. Breaks are used when you have essentially cut off part of your graph. I cut off 1, 2, 3, and 4. So if you start with a number and you don't count by that number, add a break. Okay, next, I need my line. All right, so how am I going to figure that out? Just going to show you a little bit of information, and then after that, you won't need to write that anymore. So we're going to put what we call ordered pairs on our graph. Ordered. So order matters. The first number in your ordered pair of numbers is going to be your independent variable. The second number will be your dependent variable. In other words, I want the top number first and the bottom number second. So you could also, again, look at it as the top number on your chart and then the bottom number on your chart. One more thing. The first number, your independent variable. So that 1, that 2, 3, 4, and 5, even the 73 if you are going to graph it. It's going to essentially tell you to go left or right on your graph. If it's positive, you go right. If it's negative, you go left. We won't get to negative numbers until chapter 9. The second number, dependent variable. So the 6, 7, 8, 9, 10. It essentially tells you to go up or down on a graph. I don't like how I wrote that. So up or down. If it's positive, you go up. If it's negative, you'll go down. We won't be going down until chapter 9. All right, so let's list out our ordered pair. Independent, dependent, in that order. So 1, 6. And then we've got 2, 7. And then 3, 8. And then 4, 9. And then 5, 10. So you could just look at the graph and get that information. I'm just jotting it down the first time so you know where those are coming from and what we're doing. All right, so that 1 and the 6 tells me to start at the origin and go right to 1 and up to 6. So right to 1 and up to 6, right there. Next, 2, 7, right to 2, up to 7. Next, 3, 8, so right to 3, up to 8. Next, 4, 9, so right to 4, up to 9. And last one, 5, 10, so right to 5, up to 10. Now, this is not going to be as great as using graph paper. I will know this is correct if, when I connect the dots, it forms a perfectly straight line. If it doesn't, I messed up. As you can see, I messed up. So I'm going to adjust it slightly. So the 3 and the 8, again, should be right on that line. I'm just horrible at judging right there. So the 4 and the 9 should be on that spot right there. Your dots have to be on that line because that's what type of graph linear equations make. Now, should this connect to this line or axis? Absolutely not. Not unless there's a point on it. There's nothing at 0, 5, 0, 6, nothing. So that line will not touch that graph. Don't do it. Not unless there's an actual number on there. All right, so we have graphed our information. What does this tell us? This tells us simply, as the width of a picture frame increases, the length will increase as well. I could also use this graph to predict things or to find information. For example, let's say I work at Hobby Lobby and I'm making a picture frame and it's got to follow these proportions, and the customer wants a picture frame that has a width of 3.5 inches. So what would I do or use this graph, or how would I use this graph? I would go right to 3.5 inches right there. and I could follow it up until I hit the line. I could also use the equation for this. And then I would go and see where it hits on the opposite axis, which is right there. I wouldn't recommend guessing, but that would be 8.5. So if I was making a picture frame and I needed a width of 3.5 inches, this graph tells me that I would need a length of 8.5 inches to make the picture frame turn out right. I could also use this graph to predict larger frames. So that's why it might be helpful to sometimes go further on your numbers. If I wanted a width of 6, I go right to 6. I go up. Well, I don't have the line there. So you could potentially increase it with an imaginary line to see what it would be. All right, we have one more problem. You're like, thank goodness, because this video is already at 36 minutes. All right, we have each can of paint contains 5 gallons of paint. Let V represent volume. Volume is how much of something, like filling. C let it represent the cans of paint, the number of cans. We're going to express V in terms of C. So notice it's got that shortcut phrase right there, express V. What does that mean? It means you can start writing your equation immediately with V equals. That's what that means. I could also use this chart. Remember, the top row is independent, and the bottom row is your dependent. So dependent is V. That's the one you start with typically, right? So I could use that as a means to know that I'm going to start with V as well. Okay, now let's finish this equation. It says each can is or has 5 gallons of paint inside. So what does each can mean? Well, each can, C represents cans. Each means multiplication. So if each can has 5 gallons, you're going to multiply. So if one can has, if you have one can and it has 5 gallons, you have 5 gallons of paint. If you have 2 cans and 5 gallons each, that means 10 gallons total. So multiply, C times 5. But when multiplying letters and numbers, the number comes first. So C times 5 is going to be 5C. So our equation is W, sorry, not W, that's a V. V equals 5C. The volume, or how much paint you have, will be 5 times however many cans of paint you have. All right. Second, complete the tables to show the relationship between V and C. So we're going to use our equation that we came up with. V equals 5C, V equals 5C, V equals 5C, V equals 5C, V equals 5C. Practice using or writing those equations and solving them. All right, I want to know V. It's going to equal 5 times whatever C is. So the top row is your C. So C equals 1, C equals 2, C equals 3, C equals 4, C equals 5. So 5 times 1, it's going to be 5 gallons of paint. V equals 5 times 2. That's going to be 10 gallons of paint. V equals 5 times 3, 15 gallons of paint. V, or volume, equals 5 times 4. So 20 gallons of paint. And last, V equals 5 times 5 cans. So 25 gallons of paint. Again, avoid using patterns because not everything follows nice patterns like this. I made this, so that's why it's nice. What if you had something that said, I want 73 cans? Sorry, but that pattern is not really going to help you. So you do V equals 5C. So V equals 5 times 73. And then you would calculate that. So 365. I really hope that's correct. It'd be shameful if it wasn't. All right, anyways, life doesn't always follow with patterns. Know your equation. All right, last one. we're going to graph the relationship between V and Z. So let's draw our X and Y axis. So here's our Y axis. Here's our X axis. When you look at how many numbers you have, you're going to become a better and better judge at how large to draw your graph. All right, first we need our title. What's this about? It's about volume of paint cans. Next, let's do our x-axis title and y-axis title. So our x-axis title, this is your independent variable. So the independent variable is number of cans. So number of cans, leave room for your numbers, goes down here. Oops. So again, remember, independent variable goes down here. This is not your title. You might be like, I know that. Not everyone knows that. I see it a lot. People will write independent. No, independent is not your title. Number of cans are, or is. All right, next, I need my dependent title. So dependent is going to be volume of paint, and that has a measurement, gallons. So volume of paint, and it's measured in gallons. Have to have your labels. So I have title, 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 and just a reminder, that's where your dependent goes, and no, that's not your title. I'm just telling you, the dependent variable goes right there. All right, now we need the numbers and numbers. So first, number of cans, your independent information. So 1 through 5. So we're going to start with 1 and count by ones. So 1, 2, 3, 4, 5. Sometimes it's helpful to go farther. Make sure you space your numbers out evenly. So did I start with 1 and count by ones? Yes, so I do not need a break. All right, next, 5 through 25. So I'm going to start with 5, and since it counts by such a nice number, I'm going to do that. So 5, 10, 15, 20, 25. And just one more. All right. Since I started with 5 and counted by 5s, I technically didn't leave any numbers out, so no break needed. All right, last, I need my line or my ordered pairs of numbers. So again, independent, dependent. So 1, 5. So right to 1 up to 5. Next, right to 2 up to 10. Next, right to 3 up to 15. Next, right to 4 up to 20. And last, right to 5 up to 25. All right, without graph paper, let's see if I did a good job on this one. So if I did, all dots will connect perfectly. Ew, that line's horrible. Pretend that didn't happen, right? See, you don't see it. Okay, so I was slightly off on this dot. Again, use graph paper if possible. Yeah, definitely. Don't freehand. Your dots must connect. All right, should I connect this to 0? Well, did my chart have 0 cans and 0 gallons? No, it doesn't. So you're not going to put that on your graph. That line should look just like that. Now, what could I use this graph for? Well, it tells me lots of things. It tells me the more cans I have, the more volume I have. Obviously, I could use it to predict and go further and say, if I have 6 cans Well, then I would have 30 gallons of paint and so on. Or what if I have 3.5 cans? Well, I could go up and say, oh, 3.5 means I'm going to have somewhere between 15 and 20. For that, you might want to use your equation to solve to get your exact number. All right, I hope this has helped with writing linear equations, identifying independent and dependent variables, and graphing it. If it hasn't, there's a lot of information out there. I hope you find what you're looking for. Y'all have a great day.